whale. Hello, gentlemen. What we have here is a very fine example of a Kenwood tl-922a linear amplificator. This particular version services 1.8, 3.5, 7, 14, and 21 megahertz. And it stops at 21. There's no aux position. We'll look into that. And here's a pair of 3500Zs. We're going to look into that. I'm not too sure with all the particulars that go along with this one, so we're going to find out together as we go through the process of checking it out. But this is the beginning. So let's go ahead, we'll pop the lid, we'll check our tubes and see what we've got going on the inside of this thing and what it looks like. Then we're going to check our wiring, then we'll flip it over and we're going to pull the bottom off. We'll take a look at our band selector and see if it's expandable so we can put the 10-meter position in it, which I think they all should have, but they weren't allowed to, but it's okay for us to put it in, kind of thing. Let's get started. Gentlemen, Kenwood 922A. Down in here, we got a set of really old school matchlets. Very carefully take them out. No tink on that one. Very discolored. The pins look like they're in great shape. We'll set that over there by the editing keyboard. Hopefully this one's in the same condition. That's no big deal. This is held on with a set screw right there on the side, you guys. Uh-oh. There's a cap on the top. No? Something tinking maybe. Well, once again, not very discolored. The pins look like they're in excellent condition. Yep. Let's set that off to the side. And let's go look at the bottom of it. So when I flipped the amplifier over, this little tiny lock washer fell out. Like one that would go to the anode caps. I don't know, we'll figure that out here in a hot minute. Let's take a look down here at our band switch. Let's see if this is expandable or not. Some of these are, some of these aren't. Oh, tube sockets don't look too bad. Okay, so the output network has got the 10-meter position in it, but no wire attached to it. What about the input network? The input network does have the pin, but no wires attached to it. What do we got to do here? This handle was on upside down and this was bent. This here was bent. So I took this off, this plate off, rebent the plate back square, and then retorqued the spring, because the handle, when they put it on upside down, the only thing that was holding it down was gravity, and these are spring loaded. So flip the spring around and index the spring properly. So now to actually hold the handles down. Okay, let's check to see if it's wired 110 or 220. Even though it's got a 110 plug on it, we have learned to check those things. Okay, it's wired 110. Let's grab the old variac here and let's slowly turn this duck pucker on. Oh yeah, here it comes. You're gonna hear a buzzing sound in a second, then you're gonna hear a relay latch. There it is. Yeah, we're up and running. Somebody's changed out all the lights in here to LEDs. It's 110 volts. Just over 3,000 volts shown on the plate in the sideband mode. And it should drop down to just about 2300 on the CW mode. Otherwise low. Which it is doing. Alright, well, the high voltage section didn't scatter out of the box when we turned it on. That's a good sign. Turn it off with the variac. We'll unplug it from the variac and we'll move on. Air bottle test number 1. Good. Air bottle test number 2. Good. What we're testing for is to make sure that the tubes have not lost vacuum. That's what we're looking for. And you know if they've lost vacuum because when you light the filaments, if the tube has lost vacuum, the tube just fills up with white smoke as the filament burns off. And we want to do that without the high voltage on the tubes. Because if the filament, the thing has lost vacuum, it's going to short when the filaments burn up. So to protect the high voltage circuit, we do it without the high voltage attached. Seems pretty straightforward to me. Now what I have noticed is this has got a time off timer on the fan. You turn the amp off and that fan keeps running for a couple minutes, which I think is cool. Somebody's added that as well. So that's a sales plus, in my opinion. See, the amp is off now. The switch is in the off position, but our cooling fan is still running, which it's like, yay. Pardon my hands, you guys. I was working with urethane on these batteries, window urethane, and you know that shit's like anti-seize. It gets on, it just migrates everywhere. That's window urethane. Little tiny speck of it goes every goddamn where. It sticks to every flipping thing, and it can't ever. So pardon my hands. It's not from a lack of hygiene. It's literally window urethane underneath my fingernails. So it might take a hot minute to work its way out. That's what I'm saying. It runs for about 2 minutes and then it goes click, and shuts off. See? Alright, let's put high voltage on one tube at a time. Okay, now you're going to ask yourself the question. You guys that are new to this channel and don't follow along, or you might just be watching this as your very first tl-922a video. Or any 3500Z video for that matter of fact. Why do we put voltage on one at a time? Because if we have a short, we want to know which tube it's in. So what is another 5 minutes in this incredibly long drawn out process of getting one of these things running from the blind? Like I don't know anything about this box. It was just here. This is this amp. Go through it. Oh yeah, we got zero signal and everything. Oh, that's a good sign. That makes me happy. Okay. I don't know anything about it. I've got to establish my layer of knowledge to it, just like you would on your side of the street if you were the consumer, right? Right. Okay, so high voltage is good on this one tube, and it's reacting to bias. So now we're going to let this thing bleed off the high voltage. Ah, that's interesting. The fan didn't stay on. Let's see if it catches. Nope. It caught just a second ago. Let's see, we're gonna have to watch that. That's okay. That's interesting. Let's let the high voltage bleed off, and we'll bring on tube number 2, because now we know this one is good. Remember, one of them a little questionable, and I think it's this one here. So we'll see what happens when we put high voltage to that anode. Well, let's see what happens. Contact. It held high voltage. Okay. That's on high. It held that too. All right. Plate's dipping. Plate voltage, I mean. Oh, it's working, but the grid meter's sitting a little low. The grid amp meter, or the plate amp meter, pardon me, not the grid meter, the plate amp meter. I'll see it moving. We'll have to see what happens when we whack it with a little bit of power. So on that note, let's whack it with a little bit of power. I gotta get moving on this. All right, so I'm gonna break this off into its own separate video, but I want to show you guys real quickly how to convert this thing to have 10 meters. So if you've got your tl-922a and you flip the knob and it stops at 21 megahertz and you want it to go and make it so it works on 10, you take the knob off, take the secondary drive indicator knob off, and then behind that is a little tiny Phillips screw, specifically this Phillips screw, and it sits right over here on the outside of the knob. You take the knob off, then take the the position indicator off, and then there's a little Phillips screw. You're going to take the Phillips screw out, and that'll allow you to have access to the 10 meter position. Now, all the parts are in here for you to be able to have 10 meters. They're just not hooked up. You'll find for the 21 megahertz position, which is this can here, that there is one wire, this one here, will be attached to this post here. Then you'll have a cap that goes across here and a cap that goes across over to here. And it's these caps here. These two caps here, and these two caps here. You're going to remove all of those caps. Then on the 10 meter position, on the input side, which is this wafer here, this front wafer, you're going to attach it to this point. Do not add any capacitance. The output side, which is here, you're going to attach to the back wafer on the empty spot. So you're going to have to add 2 pieces of wire. Then you add 100 puff to ground from the input on the 10 meter position. And then on the output position on this can, on the back corner, you're going to add 150 puff to ground here. And that'll get your input and your output tunes. This is your 10 meter can. This is your 21 megahertz can. Now, over here on the band switch, this is the hardest part of it all. You've got to undo these 2 set screws, and without messing up your indexing on the set screws or the wafer, you've got to disconnect everything on the band selector. And on the bottom, there's a single connector. Let's see if we can get the camera tilted down here far enough. This piece right here, that fiberglass covered connection from the tank coil, it attaches to the bottom connector on this board. You need to put a jumper between this pin and this pin here. And once you do that, bam, you've got 10 meters, just like that. But it is a trick to take this apart and make this so this works again. The trick is really this band selector here. You got to pull this cap, disconnect this wire, disconnect this, disconnect that, disconnect this, disconnect that, disconnect this. There's 2 connections on the bottom that you've got to undo. You got to undo your set screws up here in the front. Your 2 indexing screws, one here and the other one there. Undo this nut, and then you got to take out that band selector. And the reason we have to do that is because, once again, this fiberglass covered wire here is attached to this front band selector board. Well, it doesn't go to anything, so you got to run a jumper from there back to its connecting post in the 10 meter corresponding position back here on a band switch. So it's a little bit of work, but it can be done. Okay, so now we got that covered. Let's go ahead and flip the amp around and let's show it working on all bands. Okay, so it's a 1000 watt slug in peak, 1000 in average, and a 5 watt slug in reverse back from the Bird 10,000 watt dummy load. So to keep you all from getting sick, we're going to keep the amount of panning that we do. And what I mean by panning is back and forth, back and forth. It's not make anybody sick. The plate amp meter on this particular box here does not work. It's okay. The only thing it's showing you is how much current you're pulling out of the power supply. So let's look over here. Let's crop this in a little bit better. We're in 160 meter position here. We're at 1 here, and we're just below the 180 over here. That's a 1000 watt element here. So hello, we'll put about 90 watts in it. Hello, easily making 1200 watts worth of power. Let's come up here. We'll look at the SWR bridge on the front of the radio. Hello, 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 hello. Absolutely no input SWR issues. So now let's go to 80 meters. Put a little bit of AM in it on 80 meters. And let's see here. On sideband on 80, let's go to AM. Put a little bit of 80 meter dead key into it. There we go. Hello. 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 No problem. Grid. Hello, hello, hello. Dead on the money. No problem. Okay, so now we're going to go to 20. And we'll go here, here, here. Put you somewhere in there. Let's go to sideband. Hello. Hello. Hello, 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 hello. Good to go. 1000 watts easy. Sorry here. Hello. This is a 10-to-1 amplifier, you guys. So in theory, for every 1 watt I put in it, I should get 10 out. I'm putting about 90 in it right now. Hello, 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 hello. And we're getting 1300 out of it. That tells us the tubes are full chooch. We're good to go. Let's go on up here to 14 megahertz. Go back to AM. Step on the foot pedal. Pretty close. Put sideband on it. Hello. Hello. 1000 watts in the corner, pretty easy. Go to 21 megahertz. Click that on, go to AM. Right about there. Go to sideband. Hello. Hello. Hello, 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 hello. Look at the grids. Still only 100 mils, well within spec. And now let's go to 10 meters. 10 meters, 28 megahertz. Go to AM. Get that on up there a little bit. Okay, right about there. Go to sideband. Hello. 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 1200 watts, no problem. About 125 mils on the grid. So, needless to say, box is working flawlessly, except for this 1 meter. It's got the LED kit in it now. It's got 10 meters in it. It is 100% functional, and it's got a time off on the fan. Fan's still running. So, I am going to pull the tubes out of it and get it ready for transport. When you guys get this on your end, it's going to come in 2 pieces. This is going to come in its own wooden crate. So, first they build a expansion foam bladder that goes all the way around this thing inside of a commercial grade cardboard box, which is commercial cardboard, not, you know, what you buy at UPS. And then they build a custom wood crate that goes all the way around this thing, fully protects it. That way I can make sure it makes it across the United States to whoever's going to buy this thing. And then the tubes come in their own separate container that you guys will have to install. The installation of the tubes is pretty simple. Up here on the top of the anodes, you have your anode caps. Let's go ahead and shut this off because I don't feel like putting my fingers anywhere near the high voltage. And believe me, when I do this, my finger is in between the cabinet and the deck. I'm not putting my fingers anywhere near the deck. I'm a good foot away. You have to undo that screw, these 2 screws, and that screw there. This screw here and this screw here will be in a little plastic bag inside the RF deck. These 2 screws here will be tight, holding the parasitic chokes into place. And that's that. I'll have to drop the tubes in and tighten up those screws. That's it. That's all there is to it. Gentlemen, this is a Kenwood 922a, full legal limit, full output power all the way across the band. It would be a 9.5 in exterior condition, and the only downside is that this meter does not work, and I'm not going to go hunt one of these down. It's not that vital, in my opinion. The grid meter is more important to me than the plate amp meter. It honestly is. So we're going to ask $2,300 for this. No, I got to ask $2,400. I got to ask $2,400 for this plus the ride. So you guys know how this works. The first one to call me, text me, hit me up, say you want to buy it, get with me, get me the money. We'll get a shipping quote and we'll get it sent out to you ASAP. Well, on that note, gentlemen, I want to say thank you for watching, tuning in. I appreciate my Patreons and their continued support. If you guys want to think about it, come help out the channel. Come check us out at patreon.com/bbiamps.com. Come join the crew. Of course, they get first access to this video and this amplifier 48 hours before everybody else on YouTube. So on that note, I want to say thank you. Big shout out to Bird, Coaxial Dynamics, McMahon Alternators, and Siglent. Excess Power, of course. And remember, I don't get to be here without all you guys. I do not get to be here without your all support. So once again, thank you for tuning in, watching, giving me a thumbs up, smashing the subscribe button, and make sure to hit the bell. That way you can know when the next thing comes up. The next piece of equipment we're going to jump onto is an amp supply company, dual 3500Z amplifier. Bing. Gentlemen, the fan just shut off. I dig that function, by the way. Absolutely love it. On that note, gentlemen, I'll see you. And I appreciate you all. Click, click, click.